Welcome to the AI for Career Success video overview by Curt Robbins. We're experts at AI coaching and helping professionals like you and your employees upskill in AI. Today, we're looking at a significant shift in Google's AI hardware strategy, a move designed to power a whole new era of artificial intelligence.
This phrase right here, the agentic era, is really the core concept driving this entire hardware pivot from Google. It signifies a fundamental change in what we expect AI to do, and that in turn demands a completely new kind of hardware. So let's get into how Google is meeting that challenge.
Our analysis today is grounded in an excellent piece of reporting from Ars Technica. The article is titled, "Google Unveils Two New TPUs Designed for the Agentic Era," and it was written by Ryan Whitwam. It really lays out how Google is stepping away from the one-size-fits-all approach to its AI hardware.
All right, so let's start with the big question. Why make such a drastic change? Well, to really grasp it, you have to understand what this new agentic era of AI is all about. It represents a shift towards systems that are far more autonomous and capable of complex, multi-step reasoning.
You know, the best way to think about agentic AI is to move beyond seeing it as a simple question and answer tool. It's more like a project manager. You hand it a complex goal, and it doesn't just give you an answer, it actually figures out the steps, reasons through the process, and takes action on its own. And as you can imagine, that level of sophistication puts entirely new demands on the underlying hardware.
So how did Google tackle this? Well, their response was quite clever. Instead of just building one single chip that was faster than the last one, they split their 8th generation Tensor Processing Unit, or TPU, into two highly specialized chips, each purpose-built for a very different part of the AI lifecycle.
And this strategy is built on a really fundamental realization. The process of building an AI is completely different from the process of using one. You have training, which is that immense, upfront computational effort of teaching a model on mountains of data, and then you have inference, which is the day-to-day work of that trained model actually performing tasks. Using the same hardware for both of these jobs is simply inefficient.
And this is what that looks like in practice. You've got the TPU-8T, which you can think of as the heavyweight, the marathon runner, built for the grueling process of model training. On the other side, you have the TPU-8I, which is the sprinter, optimized for the quick, responsive demands of inference. It's a classic example of choosing specialization over a general-purpose approach.
Okay, so let's dig into the first of these two chips. We'll start with the training engine, the TPU-8T. This is the hardware designed for that really intensive work of building these massive new AI models.
Now, the performance numbers here are just staggering. A single pod of these new TPU-8 training chips provides 121 exaflops of compute power. To put that in perspective, that is a colossal amount of processing power, nearly 3 times what its predecessor, Ironwood, could do.
So what's the point of all that power? Well, it's all about speed. The goal is to slash the training time for frontier models from months down to just weeks. These systems are also built for incredible scale. You have pods with 9,600 chips, and they can scale up linearly to a cluster with 1 million chips. Plus, they built in things like real-time telemetry and automatic fault handling, which is crucial. It means if one chip in that massive cluster fails, the entire training job doesn't come to a screeching halt.
Google also talks about a 97% good compute rate. It might sound like marketing jargon, but it points to something incredibly important: efficiency. It means the hardware is spending 97% of its time on useful computation, not just spinning its wheels or wasting power. It's a direct measure of how much work you're actually getting done.
All right, so that covers the training side. Now let's shift gears and look at the other half of this strategy, the inference specialist, the TPU-8I. This is the chip designed to run those trained models efficiently out in the real world.
One of the standout features of the TPU-8I is the on-chip SRAM, which has been tripled to 384 megabytes. Now, why does that matter? Well, this memory is critical for models with long context windows. It allows the chip to keep more of the model's working memory right there on the silicon, which results in a significant speedup, especially for complex multi-turn conversations with an AI.
This table really brings the whole strategy into sharp focus. You can see the 7th-gen chip, Ironwood, was a general-purpose unit. But look at the 8th generation. You have a clear split between the TPU-8T for training and the 8I for inference, with a huge difference in their respective compute power. It's also worth noting the change in the CPU host. They've moved to their own Axion ARM CPUs and improved the ratio, which further enhances the overall system's efficiency.
When you look at all of this together, it really boils down to one central theme: efficiency. As these AI models become larger and more capable, the cost and power required to run them just explodes. This whole hardware strategy is Google's answer to that fundamental problem.
And this chart really quantifies that gain. The 8th generation TPUs deliver twice the performance per watt compared to the previous Ironwood generation. In the context of massive data centers where power consumption is a huge operational cost, doubling your efficiency is a game changer.
But it's important to understand that this efficiency isn't just coming from the chip itself. It's what's known as a full-stack approach. Google is co-designing everything to work together in harmony, from their custom Axion ARM CPUs and integrated networking, all the way down to the physical layout of the data centers and the 4th-generation liquid cooling systems needed to keep it all running.
So zooming out a bit, what's the bigger impact of this move? What does this mean for Google and for the AI race in general?
Well, this has some pretty significant market implications. First, this hardware will be the engine that powers Google's own future Gemini agents. But it's also a play for the broader market. By supporting popular third-party frameworks like PyTorch and JAX, Google is positioning itself as a direct hardware competitor to NVIDIA. They're hoping to address the high costs of generative AI by offering a compelling alternative for developers on their cloud platform.
And this brings us to a really critical strategic question for the entire industry. As hardware becomes this specialized and integrated, does it foster more open competition? Or does it risk creating walled gardens where developers become locked into one company's specific ecosystem? How this plays out will really define the competitive landscape for AI over the next several years.
Thank you for watching. At AI for Career Success, this is where we teach you AI and help you get smarter than your competition.
If you like these videos, use the QR code at the beginning to buy us a coffee or hire us to coach you or your employees in AI. We recommend you subscribe to the AI for Career Success YouTube channel. Please like, comment, and share to help us reach a wider audience.